Yeah, welcome again. The paper today that we want to look at is Cambridge International Examinations, that is the AS and A level probability and statistics 1, that is paper 6. The paper was taken in February, March 2017. The code is 9709/62. So the question of interest is question 7, which reads, yes, the lengths, part A, the length in centimeters of middle fingers of women in Greenland have a normal distribution with mean this and standard deviation this. It is found that 25% of these women have fingers longer than 8.8 centimeter and 17.5% have fingers shorter than 7.7 centimeter. Find the values of mean and standard deviation. Mu and this, which is the standard mean and the standard deviation, 5 marks. Roman 2. The lengths in centimeters of middle fingers of women in Snowland have a normal distribution with mean 7.9 and standard deviation 0.44. A random sample of 5 women from Snowland is chosen. Roman 2. Find the probability that exactly 3 of these women have middle fingers shorter than 8.2 centimeter, 5 marks. So part B, the random variable x has a normal distribution with mean equal to the standard deviation. Find the probability that a particular value of x is less than 1.5 times the mean. That's 3 marks. So that is our question, and straight away we dive to see how the solution looks as. Well, the question is, we are told that the middle fingers of women in Greenland have a normal distribution with a mean mu and a standard deviation that. Then mean we are not given, standard deviation we are not given. It is found that 25% of these women have fingers longer than 8.8 centimeters and 17.5% have fingers shorter than 7.7 centimeters. Then Roman 1, find the values of mu and standard deviation. That is the mean and standard deviation. So Roman 1, the first thing we remember is that z is equal to x minus mean over standard deviation. So that's what we have. And in this case, we are told that it is found that 25% of these women have. So that is about 0. In terms of probability, 25% expressed in terms of probability is 0.25. 0.25. So it means that what we are going to do is to read the value from the table that corresponds to a value of 1 minus 0.25, since the table we are using considers a value from 0 to a particular value. So that we are going to read. Then secondly, the other thing we are going to read is that we are also told that and 17.5% have fingers shorter than 7.7 centimeter. So roughly the curve would look like this, something that looks like that. So that if this is the mean, then we have our standard deviation. But then we are saying that should we take 8.8 to be here, let's say 8.8 is here, say, and 7.7 here, let me just do, okay, yeah, let me say 8.8 here. Yeah, then you realize that at such points I have this, I have that, and I also have this, and I also have this. Yeah. So I've got two regions. So we are told that 25% of these women have fingers longer than 8.8 centimeters. That is this probability. This probability is defined as that. Then again, and 17.5% have fingers shorter than. So here we are referring to this. And the probability given is this. In effect, what we then say is that we check the probability that will correspond to the value 1 minus 0.25, which will be 0.75. Probability, we check this probability, the corresponding value of z, that the value that of z that it corresponds to, we check. Then again, for the second case, because we have two scenarios, there's a scenario where longer than 25% are longer than 8.8, and a scenario where we have 17.5% have fingers shorter than 7.7. So in that case, we'll be having subtract 0.175, and that should be okay. Let's see. 1.000 minus 0.175. We have 5. We have 2. We have 8. 0.825. So we have 0.825. Now, these are the values that we check. This probability, we check the corresponding value of z, and this probability, we also check the corresponding value of z. Those values, if we equate them, if we solve simultaneously, then we are able to get the value of the mean and the variance. And so we read those values as right. Now we find that the probability that is raised is 25%, that of women having fingers longer than 8.8 centimeters. So what we do, bearing in mind that this table gives us probabilities between 0 and z, so we have to subtract 0.25 from 1 to get 0.75 as the probability. So we want to get the corresponding z value, then equate that z value to 8.8 minus mu over standard deviation. So 0.75 within the body of our table, we find it, something close to it is here, 0.7486. But then we are left with 14 to get to 0.75. So that 14, so here we have this, we have that. And then we are left with 14, but the closest we can get is 13. So we add this 13 to this, and it will give us a value which is 0.7499. 0.7499. So 0.7499, we find it corresponds to a z value of 0.674. 0.674. So it is 0.674 that we take and equate to 8.8 minus mean over standard deviation. That will form our equation 1. Then equation 2, we have the probability that 17.5% have fingers shorter than 7.7 centimeter. So in that case, we would still have to subtract 0.175 from 1 owing to this, and that gives us 0.825. 0.825 if we find it within the body of this table. Now, this table here gives probabilities between 0 and z, and whenever between 0 and z, and that's why you find this entry starting from 0.5, meaning this is area under this curve, and it's starting from here 0.5 here coming at end. So in that case, if we are to get the value for 0.825, we look for it within the body of the table. 0.825. This is big, this is small, pretty small. So we stand here. We stand here. But what is left? Because we had wanted 0.825, we are left with around 12. That 12 we can't get it, but we can get 10. So we add 10. We add 10 to this, and that is 0.8249, which is close. But then how do we get it? The corresponding Z value is 0.933. 0.933. 0.933. That's what we have. What if we added, because if this, we needed 12, not 13 per se. Yeah. So it's 0.93, no, 0.934. We have 0.934, 0.934, and that's what we take. And we are going to adopt a negative value of this, because you know that we are referring to this end from 0 going to the other end, from 0 going to that end, the left end. So we give it a value of negative 0.935. So let's see how we insert that in our solution and proceed. And we rightfully see that in the first case, as we have seen, the corresponding value of Z is 0.674. So we say is equal to 8.8 minus mu all over the variance. That is my first equation. The second equation, we saw that the value that corresponds is it's negative 0.935. Since so we are saying that is 7.7 minus mean over this, and that's what we are saying. That's the second. So those are two equations. Yeah, those are the two equations. Now, the reason why we are saying we are giving this a negative, this value a negative. The z-score value, we are giving it a negative because obviously, if you look at this, you realize that we expect the mean to be greater than this. Okay, so solving these two simultaneously, you should find, and you better solve using the quadratic formula. The quadratic formula any other time can really. Now let me see how it looks like. There's no need for a quadratic formula. Let me just see. So Avia 8.8 minus mu is equal to 0.674 standard deviation. So that should imply that 0.674 standard deviation plus mu is equal to 8.8. That's Roman 1. Roman 2 has to be this. And if I'm to arrange it in terms of this, then I'm going to have minus 0.935, that, then plus mean is equal to 7.7. That's 2. So solving this again simultaneously, should give you the value. So you don't have to, you can solve by elimination because this is already convenient. Just subtract this from this, subtract this from this, and this from this. If you subtract this from this, you are going to end up with a positive. This from this is also positive. So that gives me the value of the standard deviation that you're supposed to get is 0.684, and the value of mean that you should get is 8.34. Now you need to confirm those values using your calculator. Those are the exact values as were required. Now that's 5 marks. Then the lengths in centimeters of middle fingers of women in Snowland have a normal distribution with mean 7.9 and standard deviation is 0.44. 0.44. A random sample of 5 women from Snowland is chosen. Roman 2, find the probability that exactly 3 of these women have middle fingers shorter than 8.2. Middle fingers shorter than 8.2. So I've been using U. Now I've been using X. So as I'm saying, find the probability that, okay. So first I'll have my Z, my first stop is Z, is 8.2 minus the mean, which I now know, 8.34, all over the standard deviation, which is 0.684. Yeah, that's 0.684. If we do that calculation, just a moment, let me see. What have I done? This should be, I'm confusing this mean. I'm confusing this mean with this, and this standard deviation with this. So what I have, this is a standalone. Sorry for that. It is 8.2 minus 7.9 over 0.44. Over 0.44. So 8.2 minus 7.9 over 0.44 should give me the probability that Z is less than, because what we had required in the first place was find the probability that exactly 3 of these women have middle fingers shorter than 8.2. So the value we are going to get here, it should be 0.6818. You confirm with using your calculator. So that's this difference, and divided, you need to get that. So we see that the Z value is less than 0.6818. But then, what then is the corresponding probability? The corresponding probability is what we need. So we read that corresponding probability from the table having this value, and we read it as the probability value that corresponds to 0.6, a Z of 0.6818. Here we are told that the probability that Z is less than 0.6818. So we come here, we get 0.6. 0.6 is this. And once you have 0.6, then you move to 8. 8 has to be somewhere here. 8. So 0.68. So 8, that's this. That's that. So the value we read is 0.7517, but it's 0.6818. So we would want to find what 1 has. We find that 1 has 3. So we have 0.520. 0.520 in that case. So 0.520 if you add now 0.6818 we can round it off to 0.682. So what we do is we come, once we have 0.6, then we come under 8, we get this, then 2 under 2, so that is 0.7517 plus 7, which is 0.7524. So 0.7524 is the probability that we want in this particular case. Well, we see that it is 0.7, 0.754, 0.7524. 0.7524. That's that probability. But the question is asking, find the probability that exactly 3 of these women have middle fingers shorter than 8.2. Exactly 3. Remembering our formula, that of n combination x, p combination x, p raised to power x, and q raised to power n minus x. We could have had summation, but in this case it is fixed. So we are told exactly 3. So our concern is this, exactly 3. That should mean that find the probability that 3 of these women have middle fingers shorter than 8.2. So our n is 5 because somewhere along the way we are told the length in centimeters of middle fingers of women in Scotland have a normal distribution. So a sample of 5 women. So we will have 5 combination 3. Then the probability becomes this. Probability, that is P of x becomes this that we got here. So it is 0.7524. We raise it to power 3 because that's our x. And we should multiply again q. Q now is the difference, 1 minus this. So 1 minus 0.7524 should give us 0.2476. You should check these values using a calculator. Yeah, so 0.2476. And now it is n minus x, which is 5 minus 3. This becomes squared. Upon solving this, because you know how to work out combinations, and you are able to cube this and multiply the square of that, the resulting figure should be 0.261. That's the value, 0.261. Now that's the probability that is required in Roman 2. Well, the part B, which is the last one, the random variable x has a normal distribution. Let's see. The random variable x has a normal distribution with mean equal to the standard deviation. So mean is equal to the standard deviation. Find the probability that a particular value of x is less than 1.5 times the mean. Is less than a particular value of x. That's an observation that x may take. We find that the probability that an observation, if we pick from the sample that x represents, then we find the probability that it is less than 1.5 times the mean. So that clearly is probability less than 1.5 mu. That's what we have. And that will be, this will be probability that z is less than 1.5 mu minus mu, because that's the mean anyway, divided by the standard deviation, which I would have written as this, but it's also the same as mean. So because I want convenience up here, I will just call it the mean. So it's mu, like that. And this should imply that probability that z is less than, so this will be 0.5. Well, I can factorize mu here so that I have 1.5 minus 1. over mu. So mu goes with the mu. I end up with 0.5. I get 0.5. So it means that my z value is less than 0.5. And so I can comfortably check that from the tables to see which probability corresponds to a z value which is less than 0.5. And the value is now the required probability here. We see here that probability that we find after dividing 225 by 6,000 is 0.0375. As we had seen, we subtract this from 1 to get 0.9625. Now, 0.9625. Now we look for that probability in the body of the table, 0.9625, and we find it here. We find it there. So it corresponds 0.9, no, that's not it, 0.96, 0.96. That's 0.9625, 9625, 96, which one is close? Here it is. We get it exactly. So 0.9625. That corresponds to a z value of 1.78. A z value of 1.78. So we take 1.78 as our reading. And now let's consider the shape of our distribution. The first scenario, now here we had worked out the mean to be 8.34. That's what we put here. And the standard deviation to be 0.674. So that is our, and this is a normal distribution. So we see that that being the case, and we want to find the probability. We want to find the probability that, because we are told what is, okay, we are told, first we are told that it is found that 25% of these women have fingers longer than 8.8 centimeters. So we want to find if that is what it is. So we realize that we take from 0, have longer than. So I will say, I will put here 8.8, and then upper limit, we see that a fingernail of 10.6 almost flattens, almost makes the probability stable. So I would use 11 for convenience, and we see that the probability is 0.24, which is rounded off, it is 25%, and that probability is this part. So the probability that 25% of these women have fingers longer than 8.8% is represented by the shaded part of this area. So that is it. Then, second, let us try to see probability that of women who have fingers shorter than 7.7, shorter than 7.7, shorter than 7.7. So here we want probability. Now we talk about probability. When we say shorter than, then we should say it's here. We give it a value of we can give it 0 or 1, whichever value, because we can see with this with the division of 0.6, 1 or 0, whichever. Then here we give it 7.7, but let's give it 7.69 because it's shorter than. So we say 7.69. Now, the corresponding probability that we get is 0.1674. Rounded off, it is 0.17, which is close to the 17.5% that we are told. So actually, the part of the curve that is defined by the shaded part here defines the area that is talked about. So That is that, and that is the picture, and it marks the end of my presentation. The value is, as we have seen, 0.692, and that wraps up that particular question. So I urge you to go through it. If you didn't understand something, you can replay the video or pause as you take notes, but ensure that you follow each and every bit. Should you be having any question, feel free to leave a comment, or my WhatsApp number is also available. If you check the subscribe button, if you zoom it, you'll find my, if you go to my channel, you'll find it. So I urge you to subscribe, like, and comment. Thank you, and see you in the next video.